when we are declaring a variable, right? So the same thing goes here. Okay, so I have introduced the control flow graph, which is a graphical representation of a computer program's control or the logical structure. Okay, so what we see as a line of code, we will be translating it to the control flow graph. Okay, so that's why we call it as a graphical representation. So when we want to draw the control flow graph, we need to check on the three primitives. So this one also we have discussed where we have a decision. So when there is multiple edges coming out from a node. So for example, we need to take a decision based on the if statements, case statements. Okay. Then every decision we must end with a junction where the end of the if or end of the loop, end of the switch statement. Okay, so we need to close multiple edges back to one node. Okay, then we have process block. So process block normally the straight line. It means one node, one edge. So normal declaration, print statement, initialization, or maybe any calculation. So all this we call under the process block. So whenever we want to draw the control flow graph, we need to check on these three primitives where we try to not combine them. Okay, so we don't combine decision with the junction with process block. Okay, so I have discussed about this. So then this is something similar to the three primitives, but it is actually three different kind of nodes where we have statement nodes, predicate nodes, and then the optional part. So edges is actually the arrow liner, which is showing the flow of the program. Okay, so this one we have drawing. Okay, so the basic idea of this white box testing, it means for the given source code, we need to translate it into the control flow graph, and then based on the coverage, normally what type of coverage? Either statement coverage, branch condition coverage, or the path coverage. According to that, we will identify the path, okay, and from the path, we will be writing the test case. So based on the test case, we do the testing on different types of path. Okay, so the first three, statement coverage, branch coverage, and the branch condition, we will just go through it, and then we will be discussing more on the path coverage. So last Thursday when I draw the control flow graph, and remember I have used a formula. From the formula we need to calculate the number of path, and then we identify the number of path that is actually under the path coverage. So this is where we will be concentrating more. So your question will be more onto the path coverage. Okay? Okay, so statement coverage, the first one, the statement coverage is where is also known as a node coverage, and this statement coverage is only covering all the nodes under the true path. It means when we want to test when there is no errors happen. So it means the program is only doing the true path correctly. So let's assume when there is a decision making happen. When the condition is true, then it means the program is running smoothly without any hiccup. But when we say false, okay, it means when the condition did not fulfill, it means this is not what we expect the program to do. But when something is wrong, this is what it's supposed to do. So when we say statement coverage, it will only cover the true path. It means 100% when the system has no false condition happen. So only when the true things happen, it means the right flow has been followed. So for us to achieve the 100% statement coverage, once we cover the true path, that means we already achieved the 100%. So let's assume we use example of what is this? Okay, this one. So when we have a decision, so when we have a login, and when the password entered is correct, what will happen? It will enter into the system. It will give the access to the system. But if the password entered is invalid, then it must do something else. So it means the false part. So when we set statement coverage, once we have covered the true part, it means we already tested the program 100%. Okay? So only the true part. Okay? So it means on our first decision. So decision means we have multiple ages coming out. Am I right? So when we test the true part, it means we already tested the statement coverage 100%. Only the true. We don't need to bother about the false part. What happened when it's false? Because our coverage is only the true part. Okay, so this is the first one, statement coverage. Okay, so the second one is the branch coverage. So branch coverage is also known as age coverage, okay, where we must test every ages or every branch. Another name for age is branch also. So every single arrow coming out from a node must be tested. So it means all the true and also the false must be tested. So if we have a code which is doing the checking of the password, when the password is valid, what happened? When the password is invalid, what happened? So when just now we said to achieve 100% statement coverage, we only test the true part. We have done. But when we set branch coverage, we need to test the true part and also the false part. So it means for us to achieve the 100% branch coverage, we will test more part. It means we must cover the true and also we must cover the false. So let's assume if we have a switch statement, then it means we need to include all the cases, include the default. But if we set statement coverage, we only test the case without the default. So if it's loop, for the statement coverage, we only check when the condition is true to enter the loop. But when we set branch coverage, we also need to cover when the condition is false and did not enter into the loop. So the number of the part for statement coverage and the branch coverage, sometimes it will be same, okay, but sometimes branch coverage will have more part to test, because we want to check what happened if the condition is true and also what happened when the false part happened, which is more. We need to do more testing for it. Okay. Okay, so this is what I was saying. So with the statement coverage, we just want to check on the correct password and the control flow here going on the right way. Okay, on the correct way. But when we set branch coverage, we want to test the correct password and also the incorrect password. So we cover the true and also the false. Okay. So this is what I was saying. So normally if we don't have any if else checking, the path might be same for both statement coverage and the branch coverage. But if we have a decision making to do, then our branch coverage might be having more part compared to statement coverage. Okay, then the next one is the branch condition coverage. So branch condition coverage is where we have the branch. It means in decision making, we have two different branch, for example, for the true and the false. And inside the branch, we have more than one condition to check. So it's a combination of a branch and also the condition inside the branch. Okay, so here we will still do the checking for every branch, because we want to know the true, we want to know the false, and together with it we will have another checking of the condition to happen. Okay. something like this. So we have the branch, and then we also need to have a condition checking. So it will actually check both the branch and also the condition coverage will be covered together. Okay. So all the three is just for us to go through like that. Okay. But when it comes to your midterm, when it comes to your final exam, I will be covering more onto the path coverage. So where you actually need to translate the source code into the graphical representation, and then from there you need to do the calculation to calculate the cyclomatic complexity and then to identify the path. So identifying path is something like, okay, from here we will prepare the test case later. But in your midterm, in your final exam, I will not ask you to prepare test case. Okay? So path coverage, it means where for us to achieve the 100% path coverage, we will be testing every single possible path which is in the program. So when we say loop, so it means every time it's enter into the loop, when it's not entering the loop, so every path need to be covered. But when it comes to loop, okay, we don't need to enter into the same loop again and again multiple times. At least we execute one time, it's sufficient enough. So one time it's entering, maybe it's go to the true part. One time it's entering, it's enter to the false part. One done. So no need to be repeating again and again. Because when we say loop can be actually part of a problem for us to do this white box testing, because we cannot be repeating the path based on the loop number again and again. Okay, so that's why we execute at least one time. It's supposed to be enough for us to get the result. Okay, so that's why it is kind of impossible when there is loop into a source code. So the number of the cyclomatic complexity and the path which we will identify might have problem. It means might not be tally exactly, might be less or more, because the repetition of the path can happen again and again. Okay, so we will see some questions using the loop. Okay, so something like this. So if you see the for loop specifying that it will be repeating from 1 to 30, which will be repeating 29 times. So when we are doing a manual white box testing, we don't need to be testing this node again and again for 29 times. So when we execute at least one time, we should get the result. Okay? Okay, so under the path coverage, so we have the basis path coverage. So this is what we will be using. And then we have the loop coverage, and also we have the data flow. So for basis path coverage, okay, I don't want to discuss much about this. So we will be having a calculation, a simple calculation, which is to calculate the cyclomatic complexity. So last Thursday, after I draw the control flow graph, I have give you a formula. That formula is actually to calculate the cyclomatic complexity. So when we say cyclomatic complexity, it means based on the path of the program, we can know how complex is the source code. So I think I have mentioned that when the number of the cyclomatics is getting bigger, it means we have more paths to test. So when it say only 2, so it means we have 2 paths to test. And when it say 5, 6, it means we have more number of paths. So the more we are having a path to test, it means the complexity is higher. Okay? Okay, so this was the formula. So please do memorize this formula, okay, because the formula carry marks, and please do not get confused what you are replacing into. Okay, so VG equal to E, which is the number of the edges. What is the edges? The arrow line, which is showing the flow. Either it's coming down or going up again, all this. And then minus N. N is the number of nodes, which is the circle with the number inside. Okay, so this must be minus, and normally we will have E bigger than the N. The edges will be more than the N. Or the worst case can happen when it's a very simple code, E and N will be the same number. So it means 3 edges, 3 nodes, for example. So your answer must be minimum 2. Cannot get 1. Cannot get 0. Cannot get negative. Minimum will be 2. It means minimum part you need to test is 2 and above. Please, I don't want to see any answer in negative. Never ever the answer will be in negative. Complexity of a source code cannot be in negative. So it means maybe you wrongly put the numbers. Edges will be equal to the N or will be always bigger to the N. Okay? So this will be the formula, and from the formula we will identify the part. So this will be the flow, how we will do the part coverage testing. So we will be drawing the control flow graph based on the given source code. From there we will use the formula to determine the cyclomatic complexity by giving that number. It means we know how many parts we are going to test. Based on the part we will have the test case. Okay, we can try the test case preparation in the practical time if we have time for that. But when it comes to your midterm final exam, we will stop until 3. You don't need to prepare the test case. Got it? Okay. So this is just an example using the control flow graph. Okay. So this formula, and then replacing the number of E, number of N, and then plus 2. We always get positive numbers for the complexity. Okay. Nothing much here. Then we identify the path. When we are drawing the control flow graph, you don't need to have the additional start and end node. You don't need it. Okay, because some example they include that. You don't need to include. You always start from the first line as node 1. Okay. Okay, so let's see one example first. I don't want to discuss much about this. Okay, we will check on the tutorial question for us to answer. Okay, so I'm referring to the tutorial 5 question, which is the question 8. Okay, so based on this code, we are going to draw the control flow graph, and from there we will calculate the cyclomatic complexity and we will identify the basis part. So this is actually the part coverage. Part coverage. Okay. If you see additionally, there is another one more question asking for the branch coverage. So when it comes to statement coverage, branch coverage or branch condition coverage, we don't depend on the cyclomatic complexity. So in your midterm, in your final exam, you will only see these 3 things to do. So it means the source code given, you need to translate into the control flow graph, use the formula to calculate the cyclomatic complexity, and then list down the basis part. Done. Okay, so since it's a tutorial, there is some additional thing about the branch coverage, and then I think there is also for statement coverage on. But for your midterm and final assessment, we only have part coverage. The other 3 which I discussed, I will not include it. Okay. So let's translate into control flow graph. It's a very simple source code. Is there any looping involved here? Is there any looping involved here? No, only switch statement. So inside switch we have case 1, case 2, case 3, and then we have a default. Then we have the return 0. Okay. So please do not combine combine, decision, and junction. We try to separate that three. X equal to 0, what primitive? Process. Okay. Choice equal to input, process. Switch, decision. So how many edges we have from the switch? 4. Okay. Then inside each of the case, actually we have nothing much, just a process block. Okay. Then all these switch statement, we need to close it back using the junction. Okay. And then we have return 0. Okay. Who's going to draw? So we need to translate this into control flow graph and then using the formula to calculate and then identify the basis point. Done.
其实也是可以空间立刻，如果不是用它会长得对，就是它就全部直起来而已，就1、2、3个。
Numbering is top to down, huh? The note numbering. Multiple process, you want to combine them into one node? Yes, you can do that. You want to separate them line by line, also can. Okay, it's just that your number of edges, number of node will be more or less. But when you do the cyclomatic complexity calculation, the final answer will be still same. It means the path will be still same number, but the path might be longer or shorter. That's it.
Is it break consider process?
可以从你当做是一个有一个 can 有吗？
Why that many of nodes? Huh? Why that many of nodes? Inside the 3 branches, right? Why so many nodes?
One line, one node.
One line, one node means under each case, you still have 3 only, right? Why yours is like so many here?
3 only.
1, 2, 3, 4. Can you draw? Can you draw? I want to see your answer. Why is like too many?
我才是3个人自信。
Case 1, case 2, case 3. Is it a note? Or it is actually to indicate how many edges we have? Do you get my question? This is switch. Okay? Switch means you have a node, correct? So, is this a process I mean for you to put into a node, or this is just to indicate that I have one edge, case 1, second edge is case 2, third edge is case 3, and then fourth edge is a default. Because I think you put this as one node, this is one node, one node, one node. That's why you have like 4, is it?
Yes.
Okay, I got it. Actually, that is to indicate how many branch, how many edges we have. If I don't have that case 1, case 2, 3 default, it means I don't know how many edges will coming out from my switch. So those case 1, 2, 3 and default is not a node. It's actually indicating the edges. So you minus one layer of node.
Okay.
Okay, then inside each of the case, I can combine this actually as one node, because all these 3 is actually a process, right? So I can combine them as a node, or you want to have 3 different nodes also can. So the maximum you can have is actually 3 nodes, because you are including this as a node. That's why you have more.
Miss, the
Cut one layer of node.
lecture one, but we also got the test as the not right.
Okay, this is because we have, this is the case, is actually the edge, right? This one, we want to separate these 2 lines because we have a decision after that. We have a decision after that.
But case considered a node, right? You have to switch. I mean, you have to make decision like 3 decisions. And then for
Okay,
this, like
okay.
for this question, not
Okay, so it means it's correct lah. Then you have a case, each of it is a case, and then inside the case you will have the 3 edges, 3 nodes, correct? You have the system out, the X, and then the
Right.
break. Okay.
This is if I combine these 3 together. Can.
One.
So
It means one node.
one.
Yes.
Also, together with the case, no 2 node lah.
2. Because you guys are separating case as a node mean. So I have, this is, for example, 2. Then I will have another one. The 3, combining the 3. For him, he do 1 by 1. That's why I was like, very long. Draw your answer.
But 1 by 1,
Can also, no problem.
yeah. I mean,
If it's a process, because if you see, all these 3 is not being interrupted with any decision. So it means I can combine them as one. Unless I have this and then inside here I have a decision, then I cannot combine. So it's up to you. It's just that later our path will be more nodes or less nodes. That's it. But our cyclomatic complexity calculation will give us same number. Can you?
then
Can. These 2,
这个对的，
these 2 you combine. This one
然
is
后
a
每个人只要
decision.
想回去。
So better separate.
应
So
该一
this
样
is
吧？因为
one.
你一开始是几路，一开始是几路
after 这里不用讲是吗？下一个讲真再去那个什么吗？
You have end of the switch
要一个讲
first.
真不是？
什么讲
You have
你
this
看 after
end
decision 之后
first,
，after decision 之后有一个讲真，讲真的时候再 close 嘛。
Sitting smiling.
正常啊，I mean 我之前做也是这样玩的时候。不是啊，Is it we need a junction for closing the decision then only we do the
That's why I was
closing
saying
right?
this. The curly braces is actually indicating the close of the switch. Then we will have the return 0 after that.
Oh, so after default, they will make a junction for decision.
这个算 closing
A note for close and a note for process.
这个是 for 谁？
哦，
So don't combine
这个
the
是那个
也是跟
first
人
block
junction，
and the
讲真的时候
junction.
然后我要多一个19。
没有没有
After that,
啊，
another
这只是
one.
close
Return
，close 那个 bracket 是 close 嘛，然后它之后下面 return 它多一个 note，
你 default
这是 process。
然后就它里面内容 system
You draw your answer first.
True and false.
He doesn't want to draw. You draw first.
用
就你要20、18、19、20啊，对了。
我这是
啊
combine。
bracket 是讲是 close 之前的 junction。
This is indicating opening, correct?
Yeah.
So this is a decision. So this one is actually the closing of the switch of the decision. So we close this as one
system now
node,
don't
then
S
we
等
have
于
the
S，
process.
back 都可以 combine。
只要你 process 连在，没有，只要你 process 全部在一起，都可以 convert 一个。啊，它就是没有3个 process，所以帮你。这上面 S 还有 choice 2个 process，一个 break 一个变一个。啊，这是 decision 所以分开。
Hey, why that is going up again? Do we have a loop?
Return 0
There is no loop of going up again.
Oh, okay.
Loop is another question. We will check. Okay, draw first your answer.
我顶到这个都几很久了，对不对？
No worries, now we have a question with the loop also. We will see.
只要我顶
But this
这
one
么
no
小
loop.，
晚上我让你难
Don't
受
put。any loop yet. No loop.
不到12吧？
没有，你 decision 没有 decision 完了之后，你要把它变成一条路，要一个 junction。junction 再到 bracket close 了
You
之后再
combine
return
the
process。
three inside one process.
啊，
所以啊，return 一个 note 咯，然后 bracket 一个 note 咯 ，before bracket 一个 junction。
啊，对，这样子。
所以他们是
所以 bracket 可以讲是一根哦。
bracket 一定是一个 note。
Because there is no line saying end switch. So the curly braces is indicated as a closing, as a junction. Because
as a junction.
All the code, they have like end is, end switch, end loop, you know, like studio code. So we will have that as one line saying it's a junction. But since our code, when we have a multiple edges coming out, we must bring it first end. So that's why we assume that curly braces is presenting the junction. So we bring all the 4 edges back to one node.
So after the position, junction as a bracket, and then a process again for return.
Yes, correct.
Oh, I thought before bracket we need a junction.
No.
Oh, okay.
Since there is no code indicating the end, right? So we use the curly braces as a closing.
记录下来。curly bracket
就是 junction。没有人关了吧？开的不是，
可以不是？
开的是咩？
开了不用。
哦，是，对不起。
This the open curly braces no include.
No, because we already have the switch together with the
decision-
curly braces.
After switch just
Also, the
separate straight
closing
lah.
curly brace is like a note indicating that the switch end.
So let's assume if there is a line called end switch. So it means we have that line together with the curly braces of the closing junction.
解释也是这样。
Okay, same answer?
Yes.
Yes.
Same answer, but what's the difference? So this is the line 1 and line 2 process, correct? Okay, and then this is the switch, and then this is the case 1, and then inside case 1, case 2, inside case 2, case 3, inside case 3, default, and inside the default. So this is the decision, the junction, close the switch, and then the return 0. So the same thing goes here, but the difference is these 3 nodes. Okay, because here he's combined the 3 process line as one node, and here we are separating each of the line as 3 different nodes. That's the only difference. It's up to you. It's up to you. Let's assume you prefer, like, because you want to combine all. I want to have shorter graph. Then you can use this. When this one, if you think that this will be less confusing, because I have every node in every every line into every node, then it's up to you. So the difference will be the number of edges, the number of nodes when you are putting it into the formula. Okay, so this is our first step. From the source code, we already translate into the control flow graph. We already answered the first question. Draw the control flow graph for the above code. This is your first 2 questions. Okay, so for the second question, you need to calculate the cyclomatic complexity. So let's calculate for both of the drawing. Okay, so the formula must be correct. edges minus number of node plus 2. How many edges? Edges. How many edges? Your answer? How many edges? Too many.
21.
21. Sure.
Sure.
Sure? I'm not calculating.
Yeah.
21. Number of node? 19 plus 2. What we get?
4.
Are we having 4 parts? 4 parts. So we will list it down. So the same formula. How many edges?
14.
How many edges?
14.
Are we getting the same answer? Yes. The cyclomatic complexity must be same. It means drawing is correct. Same. It's only that you have more number of edges of nodes or less. Okay, so from here, this is our second step. It means we already calculate the cyclomatic complexity. Now the third one, you need to identify the basis part. So list down the part. Okay, list down for that, it's too long. So you have part 1, start from 1, 2, you don't want to put the circle also can, just the numbers. So 1, 2, 3, 4, 11 and 12. Then part 2, 1, 2, 5, 6, 11 and 12. Then part 3 will be 1, 2, 7, 8, 11 and 12. And then part 4, 1, 2, 9, 10, 11 and 12. So from here, you will have 4 different test cases where you will test each of these parts by giving the input to see if the part is correctly doing what it's supposed to do to produce the output. Okay, so the same thing goes, you will identify the part one by one. So the first part is 1, 2, 3, 4, 5, 6, 7, 18, 19. Then parts 2, 9, 10, 11, 18, 19. Then the third one, 13, 14, 15, 18, 19. And then the last one, 16, 17, 18, 19. So it's still same, but only the control flow graph is longer or short. So if you are clear with what you are combining, you can combine in one row, no problem. Especially like this one is a very simple code. There is no other decision or other primitive in the between of the process. So these 3, you can directly combine them into one row, no problem. You might be confused when there is a continuation of process and decision, or decision and process. So better separate them out. Correct? Okay, so there is another one more extra question here. Identify the path for branch coverage. Okay, so this branch coverage, statement coverage or branch condition coverage, nothing to do with this cyclomatic complexity. It's not depending on the cyclomatic complexity. Only the path coverage where we draw, we calculate, we identify the basis part. Okay? But when a question asks you to identify the path for statement coverage or branch coverage, it means we only refer to the drawing and identify the path state. Okay? So if you see from this drawing, when we say statement coverage, what does that mean? Statement.
True.
Only the true. It means we don't check when the condition is false or when it's not doing the right thing. So from here, if you see this is case 1, this is case 2, case 3 and this is default. So when we set statement coverage, we only do 1, 2, 3. We don't do the default because we don't care what happened if it's false. So we only have 3 parts when the question asks for the statement coverage. But here the question said branch coverage. What does that mean?
Oh, true, false.
We need to test every true and also the false. So branch coverage here means we have the same 4 part as the part coverage. Okay, but normally I will not ask the last one, only the first 3, because that is covering the part coverage. So this one is just additional. So we don't depend on this number. For statement coverage, branch coverage or branch condition coverage, we don't need to depend on this, just the control flow graph. Correct? Okay. So let's see another one more code. There is loop. Okay, so the same thing, we need to draw the control flow graph, calculate the cyclomatic complexity and the basis part. So the branch coverage you need to check, huh? Okay. If your cyclomatic complexity and the basis part which you identify, they are not tally, don't worry, you are not going to do debugging here. It means the code is having some logical issue. That's why something is not okay. Okay, so no worries about it. So if we get, let's assume from our cyclomatic complexity we get 4. Okay, from the drawing we can actually get more than 4 parts because of the looping, all this. It means the possibilities for us to have more part is there. You just need to list down 4. It's enough. Okay. Okay, so let's see here. X equal to true. What primitive? What primitive? 1. It's a process. Okay. Here we have what loop? We have do while. Where is the while? Down there. You need to check the while condition down there. Okay. So after it do the checking at the bottom, then it will go up, either entering into the loop or it's not. Correct? Because it's different. Do while loop and then do while loop, they are different. Okay? This one, it will do the action first one time, then it will do the checking to proceed. Okay? I think I have another one more, which is the while. What does that mean? It will check the condition first. If it's true, then it will enter into the loop. If no, means it will automatically out. Okay, suppose, suppose. But here it will not, because our X is already true. So it will do first. Okay. So this is a process, and then this suppose should be another node. Then this is a process, and then we have a decision for the if. Inside this decision we have another decision. Please do separate them. Don't combine. Separate them. And inside this decision we have case M, case F, and we have default. Okay. Then we have the end of the switch. We have end of the if, and then we have this while. Sorry, while. It means we have the end of the do first, and then we have a condition to check. And when we have a condition to check here, it means we have multiple arrow coming up. One is going up or one is going down, because we have a return 0 here. Okay, let's draw first. Let's see.
在下一个是
啊，看了过后了再啊，再把这个一下。
阳光，
不确定，应该是几个？你的衣服花，如果有这种，
我 if 这样子，我就是 if statement，因为还没有 else 嘛，我就 if 分了过后去一个是 for Swiss case 是
一要分，一要分，
一要分不是
哎不，一要分，撸你撸你撸你。
都没有，不知道讲。
Lisa, is it the do and the wa consider is the prescription?
Sorry, come again. Do and what?
It's not the decision, it's the.
The decision is actually here. This is the decision. Do here is actually a process. It will enter inside automatically, right? Only after it check the decision here, it's either it will go back to the do or it will go back go to the return 0. Every time it want go to return 0, it must check the condition here first. Because the condition is bottom here, not up here. Can do straight go to return 0?
Do
Cannot, because the condition is here. But when it's while on the top, then it can. Now it must come here to check the condition. Then either it will go up again or it will go down to return 0. So the decision is not here, the decision is here, down here. So from do only one edge is coming up.
is it do for the wow and then coming out to do?
Can you erase that number?
Oh, no.
Erase that one. Erase the one. Erase everything. Everything. Yeah.
sorry.
Okay, we don't need that. Okay, so the first one is the x, correct, equals to true. Then we have the do. Then this suppose should be the gender, right? Then this is our if. So this should be true. This should be false. Okay. So when it's true, it will enter the switch, and this is case F, and default. Okay. So you combine them. Then this is end switch. Correct. And switch. This is
The cross element. The bracket.
end if, right?
The junction.
This is junction for the switch. This is junction for the if.
Is it the center bracket need to cross?
No, what I'm saying is, this is the end of the switch. This is end of the if, correct? So because remember you have three different levels here. This is one level. This is one level. This is one level. So when you have a junction, also you have three different junctions. To close the switch, this is one. This is your end if, correct? This junction is when the if is false. Where it's supposed to go? 13 or 14. Means when this if is true, it's enter here. When it's false, is it coming here or here?
Here.
13. Okay. So this one, huh? Okay. Then why we have two?
Then because just now I think it's
You have one extra here.
I think so.
This is return 0. This is actually the while checking. So if it's false, it will enter here. If it's true, it will go up. This is end switch and if. Actually, I can combine these two in one loop, because when it do the end of the loop, it's doing the while checking together. So actually, this is extra. So I can have straight, because we will come back to one node, right? So 14, 15. Got it? So when it do the end if, it will do the end while, end if loop, and then it will do the checking, and when it's checking is true, it will go up here. When it falls, it will go to return 0. Okay, so let's do the cyclomatic complexity. How many ages? Yes, because we have two different level of precision, so we have two different levels of junction. So we close the switch first, and then we close the end. That two curly braces, that's a different level.
Yes.
How many ages?
So 1, 2, 3.
15. 18. 15. This is 15 as well. Fine. Because we have loop, we might be having repetition of parts again and again. So we just need 5. Okay. Part 1. 1, 2, 3, 4, 5, 6, 7, 12, 13, 14. When it's enter, okay, it will go to 15. Why? Because the X changed to false. When it's enter into these 2, it means X from true become false, then it means it will be automatically to return 0. Okay.
So we have to record also.
Logically.
So showing X equal to true.
It means it will keep on do the looping. So that's why I say we will be having repetition of loop again and again, but when we are identifying the path, at least one execution is enough. One loop is enough. 8, 9, 12, 13, 14, 15. Okay. 1, 2, 3, 4, 5, 10, 11, 12, 13, 14. Will it go straight? Will it go straight to 15? If it enter into here, will it go straight to return 0? No, because the X remain true, correct? So when the X remain true, from 14 it will go back to 2. So we assume that it must end here. Remember I told you it will always end at the last node. So you have to bring it inside here or here, then only it can end here. If no means logically it will be keep on doing the repetition. So what will happen now is when I bring into here, it means I'm repeating this part for the second time already. Because the possibilities for it to enter is there. Okay? So from 2 what will happen? It will go back to 3, 4, 5, 6, 7, 12, 13, 14 and 15. So what I'm saying is, if you see this one, right? It's happening again, correct? But now we are testing this one, correct? When it's 5 and 10. So we don't need to repeat this again just because we want to enter into this part again. No need. Okay? So we have tested this. This is all the branches. The one I'm underlining is the branches. 5, 6, 5, 8, 5, 10. Then it come again to 5, 6 here. Okay. Let's put the other part first instead of repeating that. What will happen if it did not enter into the if? We have one part, right? If it did not enter here, it means when the if is not true, correct? So it means we have another one more part coming out here. So let's put that first. 1, 2, 3, 4, 13, 14. Will it go straight to 15? Why? Is there any changes on the X? When it's enter here, is there any changes on the X? Remain true. So when it's remain true means it will enter the loop again. Correct? So now when we want to end it here, we always have these two choices. So maybe now you can choose this one instead of this one because we already repeated these two times of that part. So from 2, then 3, 4, 5, and then 8, 9, 12, 13, 14, and 15. Okay? So we have tested here from 4 to 13. Okay? And then this again. Okay, I need another one more part. Do I have any new part here which we did not indicate yet? Then we can repeat it because we need to have minimum of 5. So now we can repeat maybe this one with this combination or this one with this combination, just to fulfill it, to see what will happen. So it means if it didn't enter here, and when it do the loop, if it's go here, what happened? If it's go here, what happened? So the same thing goes if it's a default, what will happen if it's go here and here? So we have the choice of adding another one more. So let's assume if our cyclomatic complexity is 4, then this is enough. We don't need to repeat again. But to fulfill the minimum number, then you can add another one more part. So we have the choices between here and here. Got it? So let me, this one, shorter one. And another one more thing, it must end here. The end node must be safe. Cannot be hanging. Okay, so this one and this one. Okay. Got it? Okay. Loop means we might have more number parts. Actually, I can have more, another one more, right? But I don't need it because I just need 5. Because I have always more than one option every time it do the loop. That's why I said it might not be tally. Okay, so the loop test. Okay, so normally when we are having a source code doing a loop, so we need to make sure that either the loop is a simple loop. Okay, it means either it's doing the pre-checking or the post-checking, like what we have just now, the do while or while. So do while means it will do the action and then check the condition, or if it's a while, it means it's check the condition and then do the action. Okay, then loop also can be nested. It means when we are combining two different loop, okay, and then we have a concatenated and we have unstructured. Okay, so simple loop, it means it's either do the pre or the post checking, okay, to check the condition and do the action, or do the action once and then check the condition to proceed. Okay, then nested loop is when we have two different level of loops, which is the outer and the inner. So it will always enter from the outer and then it will do the inner loop until the inner loop become false, then it will go out again. Okay, then we have a concatenated. So concatenated, normally we have two different type of concatenated loop. Either it's a dependent or independent concatenated. So dependent means it means something like nested loop. It means it's depend with the output coming from one loop to decide for the next loop. Okay, but when we say it's a independent loop, it means it's just that two different simple loop working like a concatenated. So they are not depending on the input or output of one loop. Okay, they just work on their own. Okay, then for unstructured loop, it will be difficult for us to do the testing because we cannot decide. So we don't do the test for unstructured loop because we need to redesign them first. Okay, so that's about the loop part. Okay, then we have the data flow. So like what we have discussed during the static test, Here also we deal with the data flow in our program where we want to test the life cycle of a data or of a variable. So it means how the data has been declared, how the data has been used, and how the data will be destroyed successfully. Normally, this is where it can have any logical issue. So it means maybe the data is not being initialized and then it's being called, or it is being used but it's not being destroyed. So this can actually give a logical problem. Okay, so when we do the testing, the coverage testing, so we also test the loop part just now, and also we can also do the testing to check if this data flow is correctly being done or not. Okay, so nothing much about that, because as a programmer, while we are doing the code, while we are doing the white box testing, we can test all these parts. In our code, we identify the part while we are testing based on the part by part. Then if there is any issue regarding the declaration or any issue regarding the way we use the data, we can actually identify. Okay, so all this is part of the white box testing. Okay, that's it for your white box testing. I'm done. Okay, so out of the entire coverage, okay, this is what we will cover, the part coverage. So it means you translate the source code into the graphical, and then you do the cyclomatic complexity calculation, and then you identify the part. Okay, so let's have another one more code for us to draw, then we are done for chapter 5. Okay, actually the previous question, for the branch coverage, we will have the same numbers of part also, because branch means we cover every single branch. Okay, okay, let's do question 10. So question 10, we don't have do while, we only have while. So it's a bit slightly different, because the checking is not at the down but it's at the top, because the condition of while is on the top. Once we done this, we have few theory question on the top for the tutorial. We will discuss and then we will finish chapter 5. When is your midterm?
Week 6.
Week 6?
Week 7.
Week 7? Next semester.
Oh, week 5.
That's better. Next week Thursday. Week 5 Thursday, correct? I put Thursday, right? Okay. The last hours we have 4 to 6. Okay, 4 to 6. So I will be covering chapter 1 until chapter 7. So today I will finish with the chapter 5. Then Wednesday during the tutorial I will start chapter 6. And then next week I will hopefully we can finish chapter 6 this week. Then next week I will be covering chapter 7. Then on Thursday evening we can do the midterm test.
So the midterm is from chapter 1 until chapter 7. How many questions?
One question from each chapter.
7 questions.
I always give the guideline during the lecture time. Which one is important? Which one I have been repeating? That one question. One question from each chapter. So for chapter 5 I already say, this is the one. This is the 3 things. Code will be given, you need to draw, calculate, identify the part.
Only this.
For chapter, no, only this part coverage. Your final exam also the same thing, this part coverage. don't have other.
哇，哦，对的话是这个，错的话就错。
那错的话，它是哪里？
这吗？什么？还有什么东西？
我是在画空气。
就是领到 cos 两手，应该。如果还是错，我还是不理解。Really simple. The if size 是，
中会在5号。
等一下，我推这边，
中会在5号。
帮你看多一下。哇，可以。
你衣服那样子，你的那个才是放在一起，是不是？
衣服的话是seasonal的balance. If number sample then every number.
是 B， 然后是 true， 然后是 true condition。
出也就一半。错的话是那个错。
Separate these two. This is process, and this one is a decision. Okay, because it will do the checking here. If it's true, then it will enter here. Even though X is always true, okay, but we still have to indicate it will be out. Okay. Then this is process, this is a decision. So if it's true, then it will do this line. If false, it will skip this line and it will go here. There is no curly braces, huh? It means only this one line. Okay. So if it's true, it will enter here. If it false, it will go here. So this is a decision. And then we have another decision switch where we have two edges coming out. Case 1 and then default. So inside case 1, just a process. Inside the default, there is another decision. So decision here we have the true, we have the false. So even though there is no end if, there is no curly braces, we must close the end if first. We must have a junction for the if. Then you close the switch. Then you close the while. Then return 0.
就是6是7，这是水就开始。
From here, will it come straight to return 0? From here, will it come to return 0? It means, is there an edge from this node to this node?
Got the edge.
Got. Go.
就是手上。
就
if else. System out of false.这个不用 close， 那不能讲。
你 close 啊，switch case 啊，跟后面讲 close，
哪一个？
你 close 啊，switch case，
靠，switch case 上嘛，然后那个 wall 那边错了，再拿多一个才好。
就是
你 switch case 的 close 拎过去下一个嘛，然后另外一个再拿下来。你放里面点，然后注意。
Okay, it's going to draw. Where's your answer? Draw the answer.
Yes, the if the season auto pin is very number lah. The first one, the decision for if
This one?
yeah.
Okay.
The season auto pin is in very number. It consider is already go out to the return zero or
No,
still
no.
go through.
It means if this number is less than equal to 0, it will do this printing. But if the number is more, it means it will come straight here, not to end if.
So
There is
still
no.
go.
Yes. It's just like one additional note for them to print out the invalid number. But it will still go back inside the balance. So it means if it's true, it will do the printing and then come to the balance. If it false, it will skip this one and it will come here.
Oh.
So it's not going to end any if.
这样不是它不是单纯的 true false 吗？
对啊。
好像不是单纯的 true false，感觉有点怪怪。
Yes, you need to have. This one, this one there is actually no end if because it will come back to this line.
As long as there's a statement, then you can just ignore.
Yes.
是这样的。 就是它因为这个是 if statement，它如果错的话，它会去到5来才继续 balance。它如果是对的话，直接去 balance 对不对？是这样理解。
if 对的话，来这边。
if 对的话，
它出一个system error 就变成。
if 它对的话，还 print invalid number。
而错的话也是一个 balance value number。
可是那个老师不管怎样都直接去到就是不管对错都会去到balance。
是。对的话有这个，对的话有，错它就下来。下来我要再 close 它。
还在 close 一次，然后再去到balance。要 close。
好像
你好像不应该，
应该是这样。
他刚刚讲 close 吗？
他讲 extra one of bonus。
Can we off the aircon for what?
怎么遇到一个怕冷老师
Going to have stress loss here until
关
3 o'clock.
放switch 关了最小空的那个
关了
还没，还剩下上面还没有关。
关了睡着。还没。
我关了switch的话筒一个。
关了睡着，应该是
Okay, let's close so that we can discuss this question and finish up the others. This is the last book question. Then the top part.
这么大的
Have you dropped?
对吧？
Draw your answer. I want to see your answer.
然后是 cos 啊，然后给一个 cos 是吗？
哦，这里少一个17，哦，它底放一个，底放一个一分一
是这样。
那我这个问题打扰一下你，5的话去哪里
5的话就是 system， 我是去6。
去6，你没力了不是？
用这就是我的 track 在哪里？就 software。
还是要进去那个，
还是要照着。
他照进去那个 switch，然后来我这边，他就用那个。
X equal to true. Input number. If input
哦，可以啊，我知道你少
smaller than 0就 invalid 不是？invalid number 的话，怎样走下面的那个 test case？
invalid number， 如果你有 invalid number， 就是你 true 的话 invalid number， 然后继续 balance 继续 switch。如果你 false 的话，是直接 balance 了 switch， 没有 system error 都可以。
哦，像 invalid 的时候还是照样走去 balance， 就那 negative 2还是会拿 negative 2 percentage 2啊。
啊，对对对，如果这样子会拿难的。
忘了讲，它就是画出来这里。
啊，就是画了16对吧？你 cos 嘛，你 cos 出来。
这个 print invalid number 后面进来是。
先 如果打错，就直接去到这里，然后就按生气。
Are you sure your answer?
都可以看。
Are you sure your answer?
That's it.
When it comes to here, right? Here. What is your note number? Number 16.
60.
When it comes to here 16, what will happen? Means will it automatically end return 0?
No. Like this.
It means when it ends this, right? Here, how it will decide?
Need to close at the end of the month.
Where actually the decision will be happen? Is it here? Is the decision taken at this node?
Taken at the wow no.
So when it comes to the end of this part, is it not supposed to go back here? To decide either it's a true or false? So from here, will it automatically go to return 0?
Cannot. Need to
Need to?
go back.
It need to check the condition, correct?
Uh,
Where is the condition?
wow.
Here. Why I don't see any arrow going up in your answer?
Because we think it's already decision at the wow. So no need.
Okay, but where it do the decision? From here, it must check here, right? Before it can end, it need to check here, right? But I don't see any arrow edges going up again to the second here. Only coming out. Where is going up again to 2?
Oh, so maybe it's here up go back.
That is the difference between while loop and do while loop just now, right? Because do while means the while was down there. It do the checking down there before it can decide to go back or to return 0. But now, is the decision bottom there at return 0? No, right?
No.
It must go up to the second node to decide either it will come to return 0 or it will enter into. Why I don't see that answer in everyone's? I don't see the note. Sorry, the edges going up. Why everyone's edges did not go up? No need to go up.
Need to go up like it's not the same that the valid number then need to go to the wow.
Why nobody's answer is showing the edges go up? Yeah. Why no one's the edges go up to while again? They go up? Can you draw your answer? Draw the another side. Do you get what I'm saying? For you to make this decision to enter here, it means once you come down here, right? How you make the decision? Before it can go to return 0, how you make the decision? It must come back here to do the decision. Either it will enter here or it will enter here, and from here it will not end here. It will go to return 0. So 16 to 17 there is no age. It means it will not straightly go here without check here. It means from here to here there is no connection.
It's
There is no
just
age.
directly jump to.
It must from here, let's assume, after done with all this, it must come here before it can decide either to enter here or to go to return 0. So 16 to 17, there is no age, suppose. Your answer is correct or not? It is. It is. Let him draw his answer.
哦，就是区间是然后16个圈。
It's like 16 go back to do registration. If wrong, just return 0.
Your previous answer, the y is at the bottom. So once it's checked that y, it can straightly go to return 0. But now this y is on the top. So it must go up to do the checking. Then it can come to return 0. So the last statement to return 0 cannot automatically happen. So it must go up. Done.
老师讲，你回去做registration，错的话再错。
哦，这是 and switch。
总感觉那里会
就可以回去，这是两题。
用那个光。
错这里是错，这样子。
We don't draw like this, huh? It must be done.
Yeah, I like the space version.
都没有18个的，
看知道。
因为怎么的这个样子？大概18。
So if means
True.
this
For
is
5.
2, right?
This was.
False on this side. Okay. Then when it's true, it will enter this one is the print. Then this is the balance. If it's false, it will skip this one. It will do the print. This is your switch. Correct? Switch, and we don't do like this, huh? It must be down. Control flow down. Okay, so this suppose should be the case 1, correct? This should be the default. So this is if, this is true, this is false, this is and if. Even though there is no line mentioning and if, we must connect these two back. So that's why we need a junction. So this one is the process block. This suppose should be AND switch. Okay? Then this is actually the AND loop, correct? The while. So every time when we want to decide, it must go up to do the checking here because the while condition is not at the bottom. Previous question it was here. So we can directly decide either it will go back or it will be returned 0. Since our while condition is on the top here, it must come up here to decide either it will enter inside or it will go to return 0. So note 17 to 18 there is no direct edge because decision is here. So we must go up here to check. So we have 2 edge coming up. So if it's true, it will enter here. If it's false, it will be returned 0. Got it? So this is why these two nodes, they don't have direct connection. There is no edge string. Correct, huh? Yes? Correct, right? You have collected it. True will be always on this side. This arrow which is going up should be here. The one coming down is here. It means the true must be on the, is this on the left? The false is on the right. Just twist this. Correct? Okay. For what? 9 and 10?
9, but 3%.
Yeah, you can combine because it's just a process flow. You can combine the
Then the break considered a process, right?
You can just put all the 3 in one.
Also can combine 2 except break 1.
as long there is no in the between of decision or junction, it's continuous process, you can combine them. This one. Okay. Calculate the cyclomatic complexity.
21 H.
V, G, A. Formula, don't forget, Ages is what?
21
Not.
H.
Can I put my return 0 here? Actually can. Because as long we put the numbering correctly, the 18 can be actually here also. If you don't want to draw at the bottom. Because there is no connection from 17 to 18, right? No, I mean like it will still come out.
25 20
How many? 5.
5
This is the part. Is it like 1 by 1, 4?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, 17, 2, 18.
Okay, one part. Second.
1, 2, 3, 4, 6, 7, 8, 9, 10, 16, 17, 2, 18. That's half 3, right?
Wait,
Yeah, that's half 3.
For me to make just make one half like 1, 2, 18.
will it happen?
16
Actually, it's a part, right?
Oh, yeah.
1, 2, 18. Is it a part? Actually, it's a part. But will it happen? No, because our x is always true and it must enter inside for it to change to false. And the false part only happen in case 1. So when it enter into default, what will happen? It will enter into the loop again. Because the x did not change. When the x did not change, right, it means it will not come to return 0.
Only how much are for this question?
Each of the basis part carry 1 mark. So this is separate mark, this is separate mark, and this is carry a mark. Don't forget the formula. Okay. Then after that, let's assume 5, right? So I expect to see 5. So it means 5 marks for the part.
But some part like longer than my life, you know.
It depends how you draw the parts. I mean the notes. It can carry like 10 to 15 marks question. So don't lose the marks. Because my code, let me be sincere, I will not include loop. Because I know how trouble it will be. I will not include loop. So no worries. Just a simple, straightforward code. Okay? Because loop means there will be a trouble happen. When it's enter, what will happen? So you might be miss any of the parts. So I will not give loop. Only a direct. Okay, so list down 5 parts from the control flow graph. Is there logically any of the path will not happen? Okay, let's see. Let's see. If the number is 0, what happens?
Number is 0.
The num which I enter is 0. What happens? It will display the invalid, correct? It means 4, 5.
Yes.
Correct? Then after that, when my number is 0, 0 modulus 2, what happened to the balance? I'm not talking of the part, I'm talking on the logic of the code. 0 modulus 2. What is the balance?
0.
0. Sure.
Yes,
Okay, balance is 0. So when it do the switch checking, where it will go? If my balance is 0, where it will go? It will not enter case 1, correct? It will enter to default. So it will do the checking if the balance is equal to 2, correct? It will go to true or false?
False.
False. Then what will happen? It will print that please enter a valid integer number and it will go back to the loop again to ask for a new number. Okay. Because if you see, they said num less than equal to 0. Can I enter negative number here? Can I enter negative number here? Okay. Suppose based on the logic, yes. So if I enter negative 1, negative 1 modulus 2, what is my balance? Because